So, hi everyone. This talk is going to be on Mongo settings and knobs. Some of these settings people are going to know, some they're not, but I like to cover this every couple Percona Lives to remind people of things that they can do and things they shouldn't do, unless they know what they're doing. What I want to talk about today is I kind of broke it up into WiredTiger settings that I use for different reasons. I did some advanced replication and some sharding options that you can get into. This is a couple of the WiredTiger options I covered yesterday in the tutorial, but I'm covering more types of things. And also based on yesterday's tutorial, added a couple slides that we'll talk about. If you're doing an initial data load in Mongo, what are some things you can do with WiredTiger to optimize that load to be as fast as possible, on top of typical sharding stuff out and getting parallelism from that sharding. So who am I? I'm David Murphy. I'm the principal DBRE at Udemy. But before that, I was the practice manager for MongoDB at Percona. I kind of helped kickstart Mongo at Percona. Before that, I was the Object Rocket lead, which was the high-performance MongoDB as a service, kind of the initial sharded high-performance kind of Mongo. And I've done a whole lot of other stuff. I've been in the MySQL community, the Mongo community, the Oracle community for a very long time. So that's why I'm talking to you all about this stuff. That's also why I go a little deeper than you might find in the Mongo manual for some of this stuff. So with WiredTiger options, these are some of the ones that I picked. There's a few others, but these are things that you can tell the WiredTiger engine or the collection itself to do to give you a little more control over what's happening in the system. So I'm not going to spend too much time on cache size. I think everybody knows what a cache size is, what you should set it to. Don't use your whole system. The only thing I'll say here is really important is don't forget your connections. On average, Mongo has 1 megabyte per connection. So whatever you think your established connections are, factor that in. There's also sort memory and other stuff that you need to factor in, but I think that 1 megabyte is a good starting point to kind of create a buffer for yourselves. And then riff on it, watch your memory usage, but watch your evictions, all of that stuff. But we'll talk about evictions also more here right now. So evictions, this just controls how it purges data out of WiredTiger. This does it on a thread basis. And so I have an example that I'll show y'all here in a minute on how y'all do it. But in some cases, when you're trying to do massive TTLs or massive inserts, bump that up and use more of your cores and sacrifice maybe some of the sync time or log time or just overall TPS throughput in general, because these evictions will just kind of stall the system, and then you might have timeouts and drivers or other apps that would be worse than if you didn't tune down those other things. But that said, normally don't touch this. Usually only touch this if you're really trying to push something really hard and you've paused production traffic because you're doing something like a massive initial data load. You can play with this some, but in my experience, you can very easily shoot yourself in the foot, and you'll only really notice it on your primary node. So, so it's not the best place to shoot yourself in the foot. What I would say is, if you're finding yourself under a lot of WiredTiger cache seems to be micro-stalling if you're looking at FTDC and stuff like that, increasing these evictions might help you in those regards, because that stalling is probably happening because eviction can't keep up, and so it's hitting a critical mass. Not unlike in MySQL, where you get to a certain point in the buffer pool and it just says, screw the rest of the server, I'm evicting this memory right now, I have to do this. There's a few settings to control that, but similar behavior there. Statistics log delay. Who here regularly looks at their WiredTiger statistics? pretty similar to my answer to the question yesterday in the tutorial. And so what I suggest here is consider lowering this. If you're not using those statistics, what's the benefit of collecting this data? Like, it's not like, and we had a long conversation about this yesterday, it's not like Mongo's optimizer uses stored statistics in the same way that MySQL's optimizer does. So it's not that same type of statistic. This is more just, how many times have I had a right conflict exception? How many times have I done this? How many times have I done that? And it logs that to a certain log file in FTDC and some other stuff that you can use for information. But it's not that useful unless you're debugging. And if you're never using it, why not eke out a few extra TPS? That's my take on this one. The block compressor, we talked about this one as well. It's an interesting trade-off because the bigger the block size you use here, the better compression ratio you're going to get, even in Snappy or something like that. But it also means that I'm going to be evicting a larger chunk. I'm going to be loading a larger chunk. It also depends on, if you're on AWS, you probably want to align this compressor and this block size to the actual IOP size that you're on, so that you're not doing 1.5 IOPS per thing. Like, try to align to a logical number there. But that said, if you're conserving disk space, I would increase this slightly. If you're not that concerned with conserving the storage and you're concerned with optimizing your I/O throughput and optimizing your IOP usage and your network bandwidth, then probably increase this slightly. But look at your CPU, because it's all going to depend on the instance types you have, the speed of your CPU, speed of your workload, like what are you doing? It's a very variable thing. But generally, I find I only play with this when I notice that my compression ratio is just not good enough for what I'm wanting. I don't play with it otherwise because storage is relatively cheap compared to CPU, just as a general principle. So how I kind of take on that thought. So leaf page max memory, it's an interesting one. This is a really weird setting in WiredTiger that allows you to play with how big the nodes inside your B tree are that could reduce the number of rebalances you might be doing. And so could be useful, might not be useful. It all depends on, are you inserting in the middle of a leaf or are you always inserting to the right of the tree? It's very workload based. But on heavy workloads, I find that reducing this could cause it to make more leaves in my index tree rather than do rebalances. So it's kind of artificially limits the size of a B tree rebalance to kind of limit the scope and keep those in shorter cycles. The log option, this is actual pretty loaded one. There's a lot of options inside of it, so that's why I didn't cover it in too much detail here. I'll show you an example of it. But there's a lot of stuff you can do as far as turning off the log. And this is useful for doing certain things where you can tolerate data loss temporarily, or you're trying to do some sort of maneuver as fast as possible. It's kind of like turning off syncing in MySQL temporarily because you're trying to get something done as fast as possible and reduce your risk ratio. Same basic concept. Checkpoints, similarly. There's interesting inflection points on what you want to do here. So in some cases, you want really short checkpoints, so your checkpoints are all smaller, and so you're syncing faster. But in other cases where I'm doing a bulk load, and in the example I'll show you here in a second, sometimes I find that what I actually do is increase it from its default slightly so that I'm syncing less in these checkpoints, and I'm instead getting a few more of those bulk inserts in before the checkpoint occurs. You can effectively turn off checkpoints by making it really long or playing with syncs and stuff. But the settings I'll show you here in a second will show you another way to do it that is, I feel, a lot safer than playing with checkpoints and syncs as much. And sync, which I just kind of covered before, I think all of us know what a sync is. This is just how Mongo does it. The default, if I remember right, I think a checkpoint is every 60 seconds by default. Huh? Yeah. And I can't remember what the sync time is, but it's not like MySQL sync on commit. It's more like mode 2, if I remember, but I don't remember exactly what that number is, but it's in the documentation for WiredTiger. Write in memory, I talked about this some yesterday when I was talking about engines and stuff like that in the tutorial, but this is a way to make WiredTiger, according to WiredTiger, it makes it not persistent, but it's not completely true because there's a lot of metadata operations that are still occurring. So journaling, logging, depending on your other settings in the WiredTiger engine, might still have some level of persistence occurring. That's kind of pointless because there's no actual data block persistence. And so we kind of talked some about WiredTiger versus the Percona memory engine so that you would have a true non-persistence. But the thing to keep in mind about that is like what I have right here, which is Percona's memory engine is a collection level lock. And so in some cases where I'm making lots of small changes, I really want to be doing WiredTiger in memory so they keep my document level lock because it's some sort of session table or something like that, where a collection lock would be terrible for my users. No, what you would do is like there's the log setting, and I'll show you an example of doing that here in a minute, you would turn off, and that turns off a lot of the logging metadata features. And so it's one of those things that I've never understood why when you set this, it doesn't have an implied effect on certain other settings. Yeah, I don't know. It might be they did that stuff because I've never looked into it deep enough that by having that, that's how they're keeping some of the document level locking occurring. I haven't looked into like, is it really just, does the document level locking stop working and have some sort of stale weird behavior if log is turned off? It could be a thing that I haven't, but it would be, yeah. Yeah, and so I haven't looked deeply into that one, but you are probably right. There's probably settings other than log that also could be tuned down. But a lot of those things are probably nested deeply in log or other things and not well documented unless you're going deep into the source code to find them. Because WiredTiger has a lot more options than even if you're searching the source code for certain things to find the WiredTiger options, if you then dig down into it, you'll find that some of them have sub-options of sub-options of sub-options. And it's not all in like one place. You really are kind of playing find the feature in the source code. But so in bulk loading, based on our conversation yesterday, I felt it was good for this talk. What I would do is, like you see here, I've turned off the logging features, which is journaling and stuff like that. I've changed the checkpoint to 180. So I'm just increasing my checkpoints a bit more so that I'm doing a bit more work. It will still trigger on the size, as was mentioned, but it won't trigger on time. So I don't have that extra potential checkpoint if I'm writing lots of small data instead of many larger documents. Because if I'm writing 1K documents, I might hit that limit faster of the space. But if I'm writing 4-byte documents because I'm just inserting a really small integer because it's some sort of IoT very optimized pattern, my bulk load might not hit that fast enough. Anyway, so there's that. The other thing is, like I was talking about with evictions, when I'm trying to do a bulk insert or a mass TTL, like imagine that you have a really large collection that you've never TTL'd before, and you want to turn on a TTL. Two options. One is you do a looping step-down function of slowly lowering that TTL based on the number of documents that fall within an array, and so you slowly start deleting it so it doesn't just stall the whole system for 5 minutes. The other option is to do to do something like this, like actually take your whole system offline, but then crank my eviction stuff, and then crank that TTL so it runs really, really fast. It purges it out of memory super fast, and then I bring my system back up. And it all depends on your circumstance of your app. Is it better to have a longer degraded state or a shorter outage state? Like, that's a very loaded business question. But it's important to know you can do that kind of thing. I've never played with making the eviction threads more than CPUs. In theory, you could do that, but I don't think you'd get any return on investment on it, because WiredTiger does effectively use cores quite well, unless you're using like, I don't know, a 64 core machine, and then who knows what that's doing, because I try to stick my Mongo stuff onto more commodity hardware. I try not to have it on very large high compute type systems. Transaction sync configuration is another interesting one. If you're using transactions, you could turn this off. It kind of makes sure that some of those things don't also get logged to disk. But if you're not using transactions, that metadata probably never got triggered anyway, so it probably becomes a no op. I set it most of the time because I'd rather be safe than sorry. I'd rather know that I intentionally turned that off. But that's how I do a lot of bulk loading for a single replica set. But also, I was talking yesterday to the people that were attending the tutorial on, I also do a lot of work sometimes on stopping the balancer, creating chunks manually, putting them on the shards that I want, and then bulk loading into that so that it has a nice even distribution as far as throughput happening on that system. And sometimes even I'll stick different loads on different Mongo S's so that I'm getting the most throughput from the EC2 instance bandwidth that I could get.
I meant to ask you about that yesterday. So you gave an example yesterday where you might create 6 buckets, for example, and then slam 3 in. Are you creating those proverbial 6 buckets on different nodes or all on the same node?
No. What I would do in this case is I would create 6 chunks, and I would put 1 chunk on each shard. And then as I'm inserting into it, it's going to naturally split those chunks. And then when I'm done loading all my data, I turn on the balancer, and then it fixes any chunk count imbalances at that point, because that's a lot less work than if it's trying to dump everything on your default shard for your database and then trying to move stuff off of it.
I thought that's what you were saying.
Okay, yeah, because it all comes down to like just those economies of scale. It's like with partitioning in MySQL, sometimes you'll build your partition range and then insert a whole bunch of data into it so that it'll naturally split, and each of those partitions, maybe they have different underlying disks to optimize that loading speed. So that was kind of what I was kind of covering on the engine stuff. So I wanted to talk about some options for sharding that I use a lot, and it kind of ties into some of the comments we were talking about sharding yesterday as well. So auto split, they've changed the behavior a lot of how splits work in 6.0 and beyond. So this is pretty much an archived kind of thing, but auto split is something you could turn off if you wanted to load a whole bunch of data and then you wanted to manually pick your split points because you had some sort of multi-tenant structure, or you wanted to do some more fine-grained alignment and you thought that the normal splitting mechanism might not make the same decisions as you. You can still do stuff like this in 6.0. It's just they've changed the way you would go about doing that. Same thing with the balancer. I kind of alluded to it there a second ago, where there are cases where in some customers and some workloads, you turn off the balancer during your peak because you don't want it copying data and deleting data and stealing TPSs from you. And in other cases, you can't even fathom doing that during your peak because that would create shard instability and shard imbalances. Depends on how good you're like if you were using a hash shard key, you might turn off the balancer during peak just to keep movements from happening then and do your movements in off peak. If you're not doing that, maybe you wouldn't do that because it could be a little dangerous and make a little too hotness on one shard, and replication could fall behind. There's a whole bunch of side effects that could happen if you make one shard too hot. But a lot of the stuff that you might do as far as maintenance and manually clicking split points and dealing with jumbos and scanning for orphans and stuff like that, are all predicated on turning off the balancer so it's not doing stuff while you're trying to analyze the state of your cluster. Chunk size. So this is an interesting one. In recent versions, Mongo upped the size. I am completely against that change. Like 1,000% against that change. I would rather have 13,000 chunks for a collection than 6,000 chunks or 7,000 chunks for a collection if it means that I'm doing it in smaller increments and therefore I have smaller background deletes that could get orphaned and I have smaller impacts as far as like copies and stuff like that that are stealing from my normal workload. Because my belief is a sharded system should do everything it can to be balanced, but user traffic should still take priority. Until me as a DBRE says, no, 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 I'm prioritizing my balancing. Yeah, the smaller your chunk size, and there was that chart that I showed y'all yesterday, the smaller the chunk size, the higher probability that you're going to have an even storage space usage across shards. The fewer shards you have, or the fewer numbers of chunks that you have, you get into a state that you can get some really bad imbalances because this chunk range might look like it's even, but that chunk might be 128 megs and the chunk next to it might be 0 because you have some sort of TTLing or updating or deleting that's occurred on the system, and it causes the balancer to do some really weird stuff. I didn't talk about this yesterday and I probably should have. There are times too that you should probably do merge chunk. And merge chunk is where you've done some sort of change or data cleanup and you end up with chunks that are empty that throw off the balancer's understanding of how to balance the system. And the topic, just so everybody that wasn't in the tutorial yesterday knows, is we were talking about advanced management of sharding and splitting chunks and jumbos and all these management things that Mongo doesn't tell you should do, but when you start running at real scale, you need to do these types of actions, and some of them are splitting things and some of these are like merging. Because I had customers, like at one point one of the customers was like Under Armour, and they had a TTL on this one collection that was sharded, and we started looking at it and we're like, well, why does shard 1 and 3 have all the data and the other 2 shards have no data? And then we started realizing it was because those just happened to end up with 0 document chunks because of the TTL. And so once we started creating a regular process that was finding and merging those empty chunks, it was able to start healing itself from that a bit better. Well, I was at Object Rocket at the time, and we created a service that was scanning for and fixing that on our customers. And so, but yeah, you could do a cron job or a Lambda or Argo workflow or whatever the scheduling mechanism of choice in your stack might be. But like all of these things are well documented. Like merge chunk is a command Mongo documents and talks about, but they don't really ever explain to people when and how to use it, because their answer is, you should never run split, you should never run split-et, you should never run merge chunk, because it should just magically work and figure everything out. Which is true if you're just inserting into the system and everything is a fairly distributed and even thing. If it's not, you get into these super fun cases. Wait for balance is an interesting one, and it's very closely related to wait for delete. So when I am sharding a collection and I say num initial chunks, there's 2 modes that can happen with Mongo depending on what this balancer setting is. If it is not set to wait for balance, it will immediately let you start writing to it. If you have sharded an existing collection, that collection might not have gotten spread to all of your shards yet. And so you might not have an even distribution, and so you might be very hot-pinned onto your default shard still while you're trying to do your next action. So wait for balance is a good way to say, well, let me run this command, and then when this is done, it's going to kick off the next part of my script that's going to do some sort of rebalancing or data loading or whatnot, because now I know my cluster map is in a good state. Wait for delete is kind of similar to that, except this has to do more with migrations. So yesterday we talked about how, depending on the version you're in Mongo, you may or may not have secondary reads that see orphan chunks on your secondary nodes. And an orphan chunk is a migration that is either just finished and it's waiting to delete those documents, or the node got restarted while it was deleting those documents, and then it forgot that it was supposed to be deleting the rest of them. And normally Mongo tries to hide this from primaries, secondary reads. They've done some improvements in more recent versions on this, but it's not 100%, it's not guaranteed. Wait for delete is something they added, I want to say it was 3.2. And the idea behind it was, before we had wait for delete and defaulting to false, the balancer was limited in how much data it could balance at a given time, because it was waiting for documents to be cleaned up before it moved on to the next chunk. In the more modern way of doing the balancing, they send a command that says, delete this range of data, and then it's just sitting in memory, and it's kind of like a low priority delete statement in MySQL. And so it will eventually do it. It will eventually clean up that data. It's eventually consistent, all of that fun stuff. But it gets you more balancing throughput, which is great. But on the flip side, you can have some of those other weird cases. I run wait for delete in my clusters all the time, because I would rather be accurate and have more shards than inaccurate and have fewer shards.
So that means what? If you run a delete, the node reads from that node?
No. What it means is it won't move the next chunk. It won't do the next balancing action until it's cleaned up its current action. And so it makes the migration more of an atomic function rather than an asynchronous function. And then this is kind of a similar thing, and I really like this setting that a lot of people don't know about because it's fairly new in the Mongo ecosystem. The fact that you can have a completely failed shard and it can still return data to the good shards, from the good shards. Not useful in every use case, but is useful in some cases where if I have 10 shards and one shard failed, I need to make a business decision. Would I rather have 90% of my customers still get their question answered because of the way I've sharded it, my users are split, and all of their data is split onto that one shard? Or would I rather not answer the question at all until that shard comes back? The fact that we have this choice now, I love. But I cannot give you an opinion on what your stack should do there, because I don't know what your sharding mechanism is. And be very careful, because this is a global setting. So it might make sense to allow partial results on collection A, but collection B, you might get like a half-baked report on, I don't know, number of people that have taken my course, or number of people that have bought my item, or like I could run into some really interesting cases of where I wouldn't want to do that because it was distributed in an even way for throughput, not on a tenant or user kind of basis. And so this is a nice feature, but it's something to look at closely. It's a lot more options for replica sets. Has anybody here used any of these except for sync source or slave delay? What have you used?
We're doing heartbeat timeout, heartbeat interval, election timeout. I forget, two of those are the new ones and like two are the old ones.
Yeah.
We're using the newer of those.
So did you do that because you have... Okay, so you were tightening and not relaxing it. So it wasn't because you had really wide... Okay. Okay, yeah, that's a very good use case.
Also the timeout only being like 1 second,
So yeah, going through these, so chaining allowed, I think that makes sense to everybody. I think we've all done chaining in one database tech or another before where we didn't want the primary node to take all the replication hit. We wanted to create kind of a satellite pattern where we could let one of the replicas take more of that burden and maybe even remove the source replica node from taking queries so that it could focus on getting replication out to other members as quick as possible. So I think that one makes sense. It's one of those things that I think chaining is a really great thing, and I think it's really good, especially if you're doing regular initial syncs, which hopefully everybody here is doing. We talked about this some yesterday in the tutorial about how fragmentation and ordering and background indexing and all of these things can maybe not stay as sequential as we would like on the system and be far too random, or index structures might have lots of pockets of fragmentation in them. And so if you're not doing it, and I don't want to say monthly, but I'll say monthly as a starting point, then maybe you should think about that, because it's not the worst thing to patch monthly. And when you're patching, let the node resync itself. It's not the worst strategy, just to kind of protect you. But if you have a lot of throughput and you're doing lots of TTLs, you might think about an even shorter window for regular resyncs. And it's not to say that you have to do it. No, it should be on. And why did my computer go completely nuts? Yeah, it should be on by default, because it was one of those optimizations that they wanted. When you do an initial sync, they wanted it to try to pick the secondary node with the least amount of latency, but also still current for you to sync from, so that when you finished, the number of oplog entries that you needed to catch up on weren't that bad, but at the same time, you weren't always hitting whoever the primary node was to get for all the nodes. Because imagine if I had 17 replica set members and I wanted to rebuild 4 of them, if all of those tried to trigger an initial sync from the primary, your primary is probably going to hit a disk I/O utilization problem. So we kind of we're talking about reasons you do heartbeat and intervals and local thresholds and all of these types of things. And it's all down to timing. If you have a very reliable network, if you are running inside of, let's say you're running inside of US East and you're using 3 availability zones and you're not doing multi-region, you're doing multi-AZ high availability, you probably want to tune these down so that the system is much more reactive. But however, if you're doing, well, I have a node in Europe and a node in America, you probably want to tune it up because the default value is probably too short and you're going to get false positives on elections and stuff like that. And so it's very specific to your use case and what your latency is, but generally don't touch this unless you're having those election problems, because the default, I hate to say it this way, does work most of the time. But know about this so that when it stops working, you know what to do. Because nothing is worse than having flapping at 4 a.m. and not being sure what setting you could change so you can go back to bed. So max connection idle time. This is an interesting one. I find this most useful when you're in a cloud environment, such as Azure, who is very, very tight on their network and terminating established connections that aren't still passing packets. And so sometimes you need to use this one for certain clouds because the networking stack is terminating stuff abruptly. And I would rather the database terminate something than the database find that it's been terminated. And this is just a general philosophy on all database proxying or connection management. Yeah. Azure is probably the one place that I've seen it come up the most, because it's probably the most aggressive network stack as far as getting rid of established connections, where If you're doing keep alives and a few other things, and you're not using an NLB in AWS, those connections could last a really long time before they get terminated, depending on how your network's configured. Replica batch max write size is also an interesting one. So this all has to do with how many oplog entries it'll batch to your as things are replicating. The only time I've ever seen people need to tune this one is when they have lots of small operations, like they were doing increments or things like that. And so the payloads were so small with those oplog entries that they needed to tune this the system down a bit to keep it from sending like 6,000, 7,000 events in a range, and instead send 1,000 so that they had more frequent, consistent sends. But again, this is one of those ones you'll know when you need to change this. It won't be a surprise to you. Sync source, I assume pretty much everybody's probably either used this or used this without knowing they used it, because this is exactly how, when you do an initial sync of a node or a rebuild of a node, you can either let it just pick a node, or you can actually use this as part of that command so that it actually is going to a specific node. There are cases you might do that where I want to, do my initial sync against my BI nodes, and I never want to go against my other production nodes, because I don't care if BI gets slowed down. I care if the other production nodes replication gets slowed down, because that damages my high availability. I rarely see people needing to use this anymore. It was a thing that was something in the 3 series that we did sometimes. Disabling of snapshots is an interesting one. I don't see it used hardly ever. I've not found a use for it myself, but it's there, and so I documented it. We talked about election, slave delay. If you're going to use slave delay, please, 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 please always make sure that it's a hidden node, because you don't want it to decide everybody else is bad, and now you've gone backwards in time all of a sudden, and you didn't have a rollback, but you did have a rollback. This is going to be an interesting problem. So that's kind of the stuff that I wanted to talk about today as far as those hidden nodes. I think the most interesting ones are kind of that log setting and checkpoints and sync delays that you can do to get a little more throughput out of WiredTiger itself. The in-memory setting, to where if I did have a shard, and I showed this example as one of my sharding patterns yesterday. If I did have a shard, I might create a high throughput shard that has 2 replica set members that are both set to in-memory, or data in memory, or I forget the name of the setting. It's what is it called? Write in memory. There we go. That are set to that, and the third member of that same replica set is not set to write in memory. And so I do have a best effort persistence on one node, so that if the other 2 nodes crash at the same time, it would rehydrate them. And it had my session data or other tokens or other things like that that aren't critical, because it's annoying to my users if they need to re-authenticate, but it isn't a data loss event that's going to cause management to freak out that we've lost data. And so there's some strategies there if you're in a company that would rather have a certain level of caching through sharding in Mongo, rather than having 2 sets of drivers with different technologies and having some sort of Redis or Memcache true cache layer in front of the database, or as a separate thing for your sessions database. But yeah, so we covered kind of that stuff.
And as I recall, you liked that idea sometimes of having the write in memory, and then
I do like that, because when we're talking about misuse of Mongo, misuse of MySQL, state engines, session data, those are all cases that you might have that. Or even sometimes correlation log information might be a good case, where I might have it to where it's very transient data. If I lost it, it's not a big deal, but it's useful for debugging if we're having some sort of problem. And so it's nice to have a place for it to go that isn't slowing down my normal traffic that is critical for my business to guarantee persistence of. And so it's an interesting mix. Like there's an argument for doing that to keep it simple because it's all in one cluster, but there's also an equal argument for put it somewhere else and it's a separate failure domain. And well, not us, or put it in a separate Mongo cluster so that if the Mongo S's and the config servers broke, it's in a completely separate system. And it's an interesting thing, and it all depends on your tooling and your automation and stuff like that on, do I want to be running multiple Mongo clusters, or do I want to run a Mongo cluster with multiple shards inside of it? It's sometimes as simple as who's paying the bill for the database host? Do I have different products, alignment segments in my business? And so I make a cluster for each of those segments so that I can build them appropriately, and I'm not trying to figure out how to prorate bill. But I think that gets out of the DBRE scope and a little more into my architecture hat and how do I back charge teams so that they're paying for the resources they're using, and my team isn't just looked at as a complete cost center with no positive spin to it. But then we talked about some engine settings, replication, and cluster-wide settings. The other thing is, who here is on the Slack DBA chat system? Sweet. Because that is probably the best place to ask. I do watch it. I know there's other people in the Mongo space that watch that as well. And so that's a really good place just to ask a question. And I might sometimes take a while, especially these last few weeks where I've been a bit under the weather after KubeCon. It's a whole like respiratory super funness. KubeCon was not, my body did not like going to KubeCon apparently. But normally I try to be very, very responsive in those areas. And also you'd find like, if you use other texts that we're talking about at this conference, like from Proxy SQL to MySQL, there's always lots of good conversations there on those tool chains and what we're looking at as a community. And you get some really interesting feedback from some big players, such as the GitHubs and the Slacks and the Booking.coms as well on what they're doing and problems they're running into. All right, well, that is, where are we at time? Okay, yeah, we have about 5 minutes. I didn't know if y'all had any questions y'all wanted to ask.
How do we get on DBA chat?
Anybody that's on DBA chat can invite you.
I'll send you my invite. Just give me your
Thank you. Second question is on chunk size and your dislike of the larger songs and newer versions as default.
Mm-hmm.
And you had a line in there about where it breaks down on large clusters with large chunks.
Mm-hmm.
What's the threshold that you look at for where it starts to break down, and what have you done in larger chunk sizes before it comes?
So the question is an interesting one, because how many collections do you have? How many total chunks do you have in the cluster? It's one of those things that if I have 200 collections and they all have 13,000 chunks, just thinking about the logic and the timing of it, it tries to do one balance at a time. When is it going to get around to being able to do all of them? So it's that kind of timing type question to ask. And so it's very variable, because I've seen some people that have just a handful of collections on a Mongo cluster, and those, having it set to 32 megabytes, perfectly fine. Having it set even smaller might also be fine. But then I see other people that are massively multi-tenanted system where each tenant gets their own cluster or their own collection, and sharding would probably break down. And I would make the argument that if you're in that pattern, using a single Mongo cluster, you might be in a scaling anti-pattern to a certain degree. And you might think that I should only have X number of tenants per Mongo cluster. so that I could better manage those shard chunk counts in a cohesive way. Because if you have, I mean, Mongo can do it. Mongo can have a crazy amount of collections in it, and it would work. But especially as you add more shards to have different collections on different shards by default, especially if you're using separate databases for each of those tenants. And so it's really hard for me to answer that question, because you could be tall, you could be wide. But what I would say is this: just look at how much time you're spending doing balancer actions versus it not doing anything because it thinks everything is balanced. Because if you're spending more than 70% of your time balancing, that would probably indicate that either I need to break up this cluster, or I have something that is doing too much change that's causing too much friction as far as things go, and I might need to up my chunk size. I might need to move a really chatty application or service off of this cluster into its own thing because it's just chattier than the rest of the system. The other thing I would say for the same part of the topic is be very wary of different collections that have different workloads as well. Because what you can run into in this type of scenario is your chunk counts are balanced, but your collection, your documents in each collection are not of equal sizes. And so while the collection itself is balanced, because of the way the collections just end up getting distributed, you could be like, this one shard has 25 gigs more than this other shard. And it's a function of it not looking holistically at all chunks on the system and it looking at the collection that it's balancing. And this gets into what we were talking about yesterday on there's a lot of additional patterns I would like to see as far as options for you to say, what is my balancing strategy? And then Mongo could do more intelligent stuff. But I've never had the time to write it, and nobody else has written it, and MongoDB hasn't written it. So when is it going to get written? Who knows? All right, anything else? All right, well, thank you all.